All right, so now we can start officially. Hello, everyone. Good evening, those of you based in Japan in the Asia time zone. My name is Sasha. I'm in charge of events and community at Debugging Tokyo Coding Bootcamps. Super excited to welcome you all to our tonight hands-on workshop with Sam from abbeal, who's gonna deliver you a really cool, very interactive workshop about Go, a super trendy programming language that so many people heard about, but not so many people had a chance to try it on and see. So yeah, today we have beginner-friendly workshop from what I understood. So you are welcome to join and continue watching if you already have some programming foundations, if you know how to code. There's going to be some instructions shared by Sam, I think next slide. And also I posted a little bit of instructions in the chat, how to, yeah, thank you so much, Sam, how to install Go. And also if you don't have a text editor, there's like, you can also take this time to install VS Code. Just a couple of words about generally these events and why we are doing this. Probably some of you know we are a coding bootcamp in Tokyo. What we do, we teach people how to code during our web development bootcamps, and also how to use, analyze, manipulate data during our data science bootcamps. We do it in two formats, full-time and also part-time. And we also love our huge, very friendly community, which consists of people working in tech or people who want to get into tech. And for these people, we are running events like this, inviting speakers from tech companies, experts who are very eager to share their tech knowledge in order to educate and nurture our community. So I'm pretty sure that you will enjoy today's event. It's going to be really cool. I'm also preparing to code along. Thank you so much, Sam. So the floor is yours.
Thanks so much. Really appreciate it. Well, hi, everyone. I'm Sam. It's great to meet you all. Just saying, yeah, this is absolutely beginner friendly. Only thing that's not beginner friendly is the terminology. I'm not going to cover that today, but as long as you know a little bit about coding and a little bit about logic and what types are, like a string or a Boolean, you'll be totally fine and you can code along. One of the great things about Go is that it's so easy to pick up and learn, and that anyone can do it very quickly, and you have another toolkit in your tool belt for your career. You can put it on the resume, you know, basic code knowledge after this class. Absolutely. So you know, who am I? Well, one thing I wanted to point out that so this gopher right here is the official mascot of Go. It's the Go gopher. And I also wanted to pick, you know, when I colored this slide to be sort of similar blue, if you look at my head, and then you look at that, I think I was born to be a Go developer because my head is clearly the same. It's uncanny, absolutely uncanny. So I was so happy when I had this realization. So yeah, I've been a professional developer since 2002, so a really long time. That's 20 years. It seems unreal, but yes. And I've been doing web stuff the whole time. I've only done web stuff. So, you know, initially it was all full stack. I was in PHP back in the day and everything. And things have changed such a lot over that time, but and that's how long I'm doing it. For Go, I've been doing it roughly 7 years. Right, you know, it took a little time to ramp up as we switched project over, but as soon as I switched over, I loved it, and that's what I've been doing since then. And for me and my work experience and what I can advise you on, I only really worked at small companies, startups, little companies like that, and that's where all my industry knowledge is. So if you have any industry questions at the end, happy to answer those as well. And you may not be able to tell from my accent because it's a bit strange, but I am originally from the UK. I did live in America for 10 years and I'm married to an American, so my accent's gotten a bit weird over time. So, and everyone there like, where is this guy from? But that's the answer. That's where I'm from. All right. I also had the opportunity to be a co-author on a book about Go. And this is another hands-on approach to learning, lots of code examples. It's for beginners in the language as well. This actually also covers, you know, the basics of coding as well. It's for complete beginners. So yeah, check that out if you're looking to go beyond on this class. And the people that provided me today is abbeal, who I work for, fantastic company. with offices all over the world. And I recently started working with them this year when they open up their Tokyo office, and they've got lots of guys that want to come live in Japan, and they're an awesome company to work for, and it's been really, really fun. And you know, really grateful for them giving me the time to work on this and present to you guys. So yeah, just remember that name if you're looking for opportunities in the future. And so talking about the prerequisites, this is for people who want to do code along. Now, if you don't want to code along, that's totally fine. I will be speaking out loud what we're doing as we're coding it, and probably fielding questions in between times, giving people a chance to code as well. At that time, I'll go slowly and I'll really sort of talk about topics at the same time, but there's not a lot of actual typing today. But if you do just want to see what it looks like and what it can do, that's totally fine as well. But if you're feeling like ambitious and we're unsure, as I'm giving the next part of the presentation, you have plenty of time to go install Go. The current version, by the way, is 1.18. Just get that. That works great. And then install a text editor. Visual Studio Code is a really, really good option with a Go extension, and you can code along, no problem. Because I will also take you along using VS Code to open the project and how to use it as well. Right, so now we're going to get into the actual technical part of the presentation. So we're going to go through all the different things about Go and sort of the context and why it's interesting. And then after that, we'll get into the hands-on coding. So this is the sit and take notes section, and then the next bit is the bust out the keyboard and typing skills section. So who created Go? And I think who created Go is super, super interesting because it's not just the usual people that you've never heard of necessarily. The guys behind Go here, at least a couple of them, are actually sort of legendary in the computing world. So one of them is Ken Thompson. He's actually a Turner Prize winning, multiple prizes, but that's his most famous award. He was instrumental in creating the Unix operating system. And you can see up there, there's just the letter B. That seems a bit strange, of course, but that's where the language C gets its name from. It's what came after. It was the guys that wrote that together. Ken and Richie worked together on Unix. They were at Bell Labs, very famous, sort of source of technology. And Ken wrote B. Dennis Ritchie was inspired by that and created C, and C has gone on to just absolutely dominate the world. And he also, for anyone who likes to do command line stuff, he also created grep, something that we use so much. And he did a bunch of other incredible stuff. So, this guy is legendary. And then Rob Pike right here, also kind of a legend, operating system developer, along with Ken, worked with Ken for a long time at Bell Labs. He and Ken actually created UTF-8, and that is the encoding that pretty much the whole web runs on now. And he created a programming language that Go was heavily inspired by in terms of how it does its messaging and other features as well. And Robert Grossman is an awesome programmer, but he just doesn't have his legendary status is create and Go. Now, really, he was probably a huge driving force behind the language. He really sort of corralled Ken and Rob and got them to work with him on a language like that. He wrote all the details down, documented everything, and was very influential. But it's such a pedigree, and these are the three guys that really were the original creation of the language. Now, there's lots of other people that work on Go, and when these guys were all working at Google at the time, and so that actually plays in a lot to the design of the language. And there are other people that are really, really important, guys like Russ Cox, Ian Lance Taylor, and Brian Fitzpatrick. These are all guys very, very influential, but these were the original three. So that's why they get their own slide here. So why did they create Go? That seems, so they were working at Google. And what were they doing at the time? They were creating server software. That's important. That influences a lot of things. They were writing code in a large C++ code base. And things about C++ is it's a compiled language. We'll talk about it a bit more, and it's really, really powerful, and it adds on features to the C language. And they were working in large teams. So why these are important? Well, one thing that they noticed is that servers at the time were getting multi-core processors. Now, it seems quaint to think about that now, but they were like, that's the future, multi-core processors. Well, yeah, we all know that now. Multi-core is everything. But the languages of the time really weren't good at taking advantage of that. There was a slow compile time. The legend goes that they actually came up with the idea to create Go while waiting for their code to compile. So and really the reason is productivity. Like when you get a large code base with lots of people working on it, they're thinking about productivity. They're thinking about how to make a practical language, and also with the language it was very open and flexible. They could define anything they wanted, but it was hard to onboard people. So maybe the flexibility and expressiveness of the language was also holding back productivity. So they had some very clear goals. They wanted simplicity, safety, and readability. And these were all related to those problems they were seeing for, which was related to the context they were in. So that's one thing I definitely want to say with Go, is that it's a language with a real goal. And it's not about being cool, fun, interesting language to code with. It's about being a very practical, useful language for professional developers to get work done. And that really influences a lot of things about the language. And these goals were according to Robert Grossman as well. So simplicity, make a language that's easy to learn, and they absolutely killed it. But if you're going to make something easy to learn, you're gonna not have everything, because you have to say, well, there's one way of doing something. Because if you have multiple ways of doing things, it's actually hard for people to learn and teach, and reading code from different people looks different. So this one way of doing everything is part of what Go is about. Is they really pared it down to a simple language. Safety. So the language they were using, it could have issues of buffer overflows, and those are really big problems when it comes to reliability and security. So they wanted a language that was memory safe, and that's what we mean when we talk about safety. And we also talk about a very clear, simple type system, not a very complex one that you can easily make mistakes in. And also a language, when they're thinking about multi-core processors and taking advantage of lots of CPU cores all at the same time, one that prevents race conditions, one that prevents situations where work is happening in an order you don't expect, and which people that have worked in JavaScript will know very well. When you're firing lots of different events in the browser, things can happen in a strange order sometimes, not what we would expect it to do. And readability. This is something that I think a lot of developers who haven't worked in a professional environment don't realize, is that you spend way more time reading code than writing it. You spend a lot more time trying to understand what code is doing rather than designing new code to go into it. And a way to become more productive is to make that easier to understand, to read, to have everyone have a level of consistency. When you have easy to understand, easy readable code, it's easier to make changes to that code without introducing new bugs, because you didn't quite understand what it was really doing. So that means that it's also easier to extend. So adding new features becomes easier when your code is easy to understand. So very, very important. And then to reiterate, practical. Now, this isn't one of their goals, but I think it's something that sometimes when you try and compare it to other languages that have all of these features, and why doesn't Go have these features? Well, not having features is a feature. This is the less is more mentality to programming languages. Now, Go did take from a lot of other languages. There's nothing really new in Go, but they really, really looked at other languages, and they wanted to decide what was absolutely the best. They also looked at certain features and said, in hindsight, that was a mistake. They shouldn't do that. So there's certain features that every language has, well, Go doesn't have it, and that's a bit strange. And so why a feature is missing is because they chose not to include it. And another big part of this is that when you design a programming language, you're trying to design this very pure specification for the syntax and the way that it all works together, and different parts of the code can, work seamlessly together. But creating code is more than just creating software is much more than just the language. There's a whole ecosystem that goes along with things. There's toolings, and there's dependencies, and there's writing tests, and deploying the code. All of these things are part of the ecosystem of what it takes to actually build real software in the real world. And they were not afraid to go beyond the language spec and say, we're going to provide you with tools to also help do that. Once again, it's a practical language. It's not just a theoretical thing that is like, this is the perfect programming language, but it's not necessarily great to use in practice. So now let's go on. So what is Go? So what are the features that Go has? So we've got in the context, and we sort of understand what they were going for. So what they actually end up building. Well, before we go into that, you may be confused because you've sometimes heard it referred to as Go or Golang. The name of the language is Go, but it was created in Google, and they understood search engine optimization, and they realized they'll never get any search hits if they use the word Go in their text. So Golang is used to make things easier to search, because nothing else is really using Golang. So when you're reading stuff online, it'll always say Golang, and that's because it's an easier search term. But the name of the language is Go. So let's dig through some features of the language. So it has a C-style syntax. So if you've ever seen JavaScript, then this is exactly what it looks like. Java itself also has a very similar syntax. PHP, many languages have this syntax, and I'll show you an example just in a little while. It is statically typed. That means that once you define a variable, you cannot change its type. It's fixed. You can't modify its type after the fact. It's compiled. So with other languages like Ruby or JavaScript, you just sort of put your scripts in a folder, and then something comes along and runs them for you. There's a different aspect to it. For JavaScript in the browser's running it, it's executing it, or Node.js is running it. Or if you're using Ruby or Python, they have a runtime that's separate. You need to install separately. You point that runtime at the scripts and it runs them. Well, that's not how Go works. It's compiled, and it's fully compiled. So for example, Java also seems compiled, but it's not. It also needs a runtime. It's only compiling down to sort of an intermediate language, same with C#. These also need runtimes. Go doesn't need any runtime. It's completely, you compile a single binary and it runs all of its own. It's memory safe. So as I said, that means that, they make it very difficult, not impossible. They make it very difficult to cause things like buffer overflows or using memory how you shouldn't do. The only way to do it is literally a package called unsafe. So, they made it clear you still have the power, but it's unsafe when you're doing it. So, beware as you go through. It has a garbage collection system. So that means that memory is managed for you. You don't have to say, give me a megabyte of memory and then I give you that memory level. It's all taken care of for you. So that once again is a productivity feature as well. And it has this, it's called a CPS style concurrency. We won't go too much on that today. We're going to keep things very simple and not get into concurrency. But the idea here is that we are going to be able to use all of our cores of our CPU from one single running application by passing messages. We'll pass a message to other parts of the code and they'll run them. And this will synchronize our code and prevent race conditions, which we mentioned earlier. So it allows you to very much take advantage of all the power of your CPU, without you having to really understand how that works. You just use it. You don't even need to know how many cores you have. There's no need. Go will take care of that. You just say, run all these tasks and Go will run them for you. This is probably the thing that people coming from other language with experience of trying to do it in other language really praise Go for getting right. It makes concurrency and parallel work very straightforward and enticing. And, often it's something that new developers into language overuse. So it's probably the overuse feature for new developers because they want to try it and it works so great, but it's often not necessary. But when it is necessary, it's there and it's fantastic. It's modular. So Go does not have a traditional hierarchy system. It doesn't have classes, and you can't inherit from a class to class. So there's no real inheritancy. That was something that the creators said, I don't think that really works in real code. And now this is quite a controversial statement because it seemed like that was just a default feature. And you would need real mavericks, real legends in the language to be able to pull that off in modern day, but they have. But it doesn't mean you can't have code isolation and you can't have nice compact pieces of code that works closely together with some public and private aspects to it. So it's modular in that same way. So you get all of the benefits of object-oriented code, but without that feature that we feel that maybe is causing people to design things that they regret later on, essentially. It has a feature of generics. This is a relatively new feature to the language, and that is allow you to have reusable code across the same types, different types. So before generics, if I wanted to do some kind of sorting of a collection of variables, say they were numbers or they're strings, I would need two different functions, even though they do the same thing. I can just compare them and see which is higher and which is lower. But generics allows me to reuse the same code with different types. So this is very much sort of getting beyond that static type system. So it's one way around that. And the other thing that Go doesn't have is exceptions. So if you're used to a language with that, it doesn't have exceptions as well. So this is just another example of them saying, I think this feature causes more problems. We need to really handle our errors better. And you'll see that in the code that there's a lot of error handling, but that is by design. So that's the language features. But and that's what you will experience when you are writing the code. But when you're running the code, that uses a runtime. That uses essentially an environment. And so Go has its own, it's compiled into the binary. And one thing it has that it's really, really optimized well for is low latency. The garbage collection in many languages is a bit that makes a program sort of stutter or hesitate. And Go has very much optimized for low latency. And when I say low latency, it's the difference between getting a quick response or getting a lot. So it's if you turned on a big water pipe, it might take a little while for the water pressure to build up until you get all that water coming out. And then it will come out and you're getting a lot. But a small pipe, you turn that on and you get the water comes out really quickly, the pressure builds up. So that's low latency, that's small pipe. And Go's sort of crowning glory here is that it's essentially getting close to real time where there is no pause. 500 microseconds is half a millisecond, and there's 1,000 milliseconds in a second. So, it's incredible how quick these are. It compiles really, really fast. So the problem with the other languages, of course, is that they can be compiled and run really great, but it takes a long time to actually develop because you're waiting for the compilation. Even on large projects, it takes a few seconds to compile Go. And then execution is fast. People build all kinds of really high performance systems in Go, and you often don't have to worry, about your performance. It just runs great. And cross-platform. So I can develop code that will run on Windows, run on Macintosh, run on Linux, run on ARM processors, run on all kinds of different things, and it does that. Now, it's not the same binary. I have to cross-compile for each target platform. So that's like when you go to download a piece of software, it says, do you want the one for Windows or do you want the one for Mac? That's the equivalent that you can do in Go. So that's really, really awesome. And then ecosystem. What is it like to work within the ecosystem? So go beyond the runtime. The standard library that comes with Go is fantastic. Everyone has such high praise for it. And it's, one thing it has is it's really production ready stuff. A lot of the standard libraries that come in other systems, people say, it's not really good enough to use. You have to sort of use the community established ones, but most of the time people are going to drive you to the standard library, and it includes a production level web server. So your web server is built into your code. You don't need a separate one, and it is more than good enough. It is really high performance. It comes with a built-in testing framework right into the Go compiler. There is dependency manager. So yeah, lots of open source libraries for you to use in your code, and they're really, really great. And those tools for downloading and managing the versions built right in. It is open source. There is a debugger available if you like to debug, and there's lots of great profiling tools for profiling memory, for profiling execution time. Really, really great. So what does Go look like? Well, here it is. It's really, really simple. Hello world. And that's what it looks like. You always have to have a package statement at the very top. And to make something that's executable, that package is going to be called main. And today, we're going to be working in main. We'll be writing these out. If I want to use something from the standard library, I can import it. So I'm importing here the formatter library. And then for our executable code, the runtime needs to know what the entry point is. So the entry point for Go is the main function. So here we go. We have an executable right here. I can compile this and run this, and it'll run great. It's very, very straightforward. So let's look at some stats. How popular is Go? It's a little bit out of context. So, maybe this will give you an idea of if it's big enough or popular enough to use, and what it's being used for as well. So my source for this is this blog post. So it's published February 2021. And also the data within it is a little bit older as well. So these numbers are all older, but I think they're totally fine. And you can just sort of extrapolate from there what's going on with Go. So roughly, over 1 million full-time developers using Go as their primary language. There's probably, this article said there's probably 3 million people using it as a secondary language, but this is their primary language, what language they use. I think they get to pick 3 in this survey, but this was one of them. They're using it. Where do people use it? Well, you can see Asia actually is the most populous place of people using Go. Very, very popular in China, actually, Go is, and how it's sort of spread all over the world. But yeah, we absolutely dominate here in Asia for Go use, so definitely a great choice. And here's the breakdown by country, and you can see the top 2 here are China and Japan for professional developers using Go, according to this survey. All surveys are flawed, of course. This just gives you an indication, and then there's the breakdown of different countries and what how much they contribute to the overall numbers. So what are they building in Go? Well, mostly web services, and that's where it really excels, is for building web, APIs and sites. And then you can see there's things like utilities. And so that'll come actually into the next one, which is IT infrastructure, really, really popular with DevOps. And that's sort of what covers these things. It's the DevOps are using those utilities. Because Go compiles down into a single library, it's easy to share and execute. And then you can see we've got things like databases. Really that's big. People are actually building databases with Go. And then we got some machine learning, but I think it's more business intelligence people. They're doing the stats, they're doing the numbers on their stuff. But what you don't see in here is games. People aren't making games with Go. They're not making mobile apps with Go. So if that is your area, this is not the right language. This is much more your enterprise business backend services, working with data, working with big servers, working in infrastructure in the cloud. If those things excite you, then it's great. What are some killer apps you may have heard of? So these aren't necessarily the biggest things. These are just things I wonder, maybe someone has heard of these. I think every language needs the killer app to really, make it stand out in the community. For the DevOps side, they've got a lot. It's, as DevOps was becoming a thing, Go was really hitting at the same time. So it was a very, very popular language. So Docker is written in Go, Kubernetes and Terraform, all written in Go. These are, if you've ever had to do any work with your DevOps team or cloud or infrastructure, you'd have worked with these tools, and they are written in Go. And you may not have even known it because, oh yeah, so someone shared a thought that, I made a statement about games, and I will come back to that as well. You can do anything in Go, but I'm really focusing on what the professionals do. What are the industry people are doing as well? So yes, you can absolutely write games. There are game engines in Go, and there are backend services for Go. but it's more the hobbyist level right now, I would say. It's not, so you'll be hard pressed to find a job in those industries with this language. So just to make that clear, sorry about that. Yeah, databases here. We've got a number of databases. You may not have heard these, but InfluxDB is getting quite well known in the DevOps space for collecting logs, time-spanned logs and stuff like that. But, it shows you the power that, performance you can get out of a straightforward language. And then over here, you've got things like Snap, which if you've done anything in the sort of Linux Ubuntu world, that's their package management system. A lot of their backend services written that. Hugo is a blog, static blog generation tool that's really, really popular. And then Ethereum, the first implementation of the Ethereum sort of virtual machine runtime was written in Go. So, a little bit, that one's a little bit of a stretch, but, it's not Ethereum that's written in Go, that's for sure, but, it was popular there. So just so you know that it's being used in quite significant things. So what is the community sort of like? And I think community is such an important thing to know when getting into a language. It really, sort of gives you an insight to the sort of people you'll be working with. They very much prefer performance and efficiency over a beautiful API. So this is not about elegant code necessarily. It's not about beautifully designed, elegant APIs, everything else is sacrificed for the absolute joy of program. Nope, they want efficiency. They want it to run fast and they want it to use as little memory as possible. But they still want it to be good, but it's all about priorities. You can't have everything. If there has to be a trade between a bit of an ugly API and good performance, that's what they're going to do. They will tell you to start simple. This is the advice whenever people come into the community saying, what web framework should I use? What this should I use? What that should I use? They'll always say, start simple. Don't worry about using a hexagonal, architecture within your code. Don't worry about what folder you use. Just start simple, get going. And over time, as you feel pain, then start to look for solutions to that. But just start with the standard library. And direct communication from Go people, they won't sugarcoat anything for you. They're going to tell you, if you are making a poor assumption, they'll tell you. Now, this I bring up because I don't want anyone to be offended. They tend to be very practical minded, as I say, the performance side of things. And and they're just going to tell you like how it is. And that's the sort of community in the English speaking side of the community that is. I don't interact with any of the other ones. And so that's just something to be aware of. So don't worry if someone gives you a bit of a short reply to your request. That's just the way they are, but they're still a community. So why is Go cool? So it may not be obvious. Well, I get it. It's got cool features and it's got some good lineage and heritage, but what would I actually use it for? One really cool thing is stability. Old Go code still works. So there's something called the version 1 promise, and that is that the Go language promises never, ever, ever to break your code as long as it's the version 1 of Go. So any code written for version 1 of Go, and that means 1.0 up to 1.18, the old code will still work in the new compiler. And that is absolutely true. The only time things are changed is when there are bugs, and unfortunately, if you coded to the bug, that's fine. But even then, that's more security-related issues. Sometimes they've had to be more restrictive. But I think we would want that anyway as a compromise. But yeah, people are always shocked when I say, just any tutorial online should be fine. It doesn't matter if it's a bit old. There's only a couple of things you need to know that are different and new now, because a lot of when you go with languages and you go to the old tutorial, they don't work anymore. You go to videos on YouTube, they're not relevant anymore. They're dated. Things have changed. People have moved on. If you've done any React development, I think the React tutorial industry is probably just as busy making content as the actual language developers as well, because it's constantly changing. We have to keep up. We have to put out new content to help those poor people out. What you compile is really self-contained. It absolutely doesn't need any dependencies, and that's why you can have something like Docker or Kubernetes. It's just something you install. Well, really, you don't even install it. You just copy it onto your computer and it will run. So no dependency needed. It's very, very simple. When you create a tool, you can share it with your friends. Just say, are you on Windows? Okay, here's your binary for Windows, and your tool will work. That low latency, one of the things it really allows for is a microservice architecture, which is very, very popular in the back end. Low latency means that you can have tens and tens, even hundreds of services all communicating with each other to fulfill one request. This allows for really great architecture and management, clean code. It's enabling that is fantastic. And it's actually the reason I moved to Go, because I wanted to do microservices, and PHP was really holding me back at the time. Things have really changed now, but yeah, that's how I discovered Go. Even though it's a strictly typed language, and you can't change those things, and it's compiled, in use, it doesn't really feel like that. It actually feels more like using, like PHP or JavaScript, where it's more loosely typed. You don't have to be so verbose on everything you write. So it's sort of almost getting that best of both worlds, that real blend of being productive, but also have all the performance benefits you get from that. And so what Go is really, really, really great at is building apps. That is its absolute sweet spot. You can build the best web backend apps with Go. They're going to be super high performant, easy to maintain, and easy to introduce other people onto the team. That is its absolute best thing. It can do all kinds of other things too, but that's its hotspot. There's other languages coming in, like Rust, for example, that really are starting to take away some of the more system level tools. But in terms of building apps, it can't touch it. And then that concurrency, we touched on it before, the concurrency, being able to use all the resources, all the CPU power on your system in a really straightforward way, it's killer, absolute killer feature. Well, then what's the catch? What's not so good about Go? And to clarify, you can do all of these things in terms of the computer games, but in Go, but not necessarily at a professional level. It's more of a hobbyist level. So it's possible, but I don't think there are businesses really investing in these industries in Go. So full stack development, yes, it's possible in Go, but it's just not that popular. People do build them, but they tend to be really straightforward, sort of not very dynamic web pages. So Go tends to be the API that a React web front or Angular web front is calling into. But actually building the front end in Go, it's not really, there's not some really very popular good solutions for that. Doing embedded or Internet of Things, it is possible. There is a compiler called TinyGo that allows you to run on these very small, tiny devices. But because Go was designed to be run on servers with multiple cores, that really holds it back in that situation. So it's possible, but you have to really want to. Yeah, as I said before, people aren't building front end, their computer game clients, desktop apps, mobile apps. It's possible. There's libraries out there, but it's it's not very. You're going to struggle uphill, and there are better options to do. You can do AI and machine learning in Go, but Python is going to just walk all over it, mostly because of the community behind it. All the libraries and the knowledge and the tutorials are all there. Go is looking promising though, and it's showing promise. I think people are starting to look at that and say, maybe this is a better option for us, especially as those projects get bigger and bigger, which they're of course going to do. And as an expressive language, and a language where you can really write elegant, beautiful, concise, APIs that you just absolutely fall in love with. No, you're making compromises constantly with Go in the way that it looks. And that's something that you have to be okay with if you're going to do it. All right, now that brings us to the end of section 1. So we're going to take a break now for 5 minutes. So go ahead and refresh your drink. And we'll be back at 7:45 or 19:45, and then we'll get going again. If you have any questions, feel free to answer away.
Is it a good time for people to open the terminal and a text editor, right?
Yeah, I guess it's good time to open those up. But I'll be doing it along with you as well. So yeah, go ahead and get your editor fired up. Go ahead and get a terminal open, and but we'll folders and everything together. I'll take you through start to finish, so no need to worry. So I had a question. All right. So one of them is, could Go be a good thing for things like WebAssembly? So Go does cross-compile into WebAssembly. Absolutely. So the difficult thing is that there's a certain overhead, and it depends on what exactly your project is. Some good examples is if you wanted to have exactly the same validation logic and exactly the same, say, password generation logic or encryption logic, that would be a really good example of where I want consistency both on the front end and the back end. But it's sort of hard to justify, using Go for most of the things you want to do in a browser. So I think WebAssembly has a lot of fantastic promise, but I don't think anyone has really found its niche yet. So yes, Go already supports WebAssembly. It works great. It compiles down to quite large size though. So because there's a whole runtime that goes along with it. And so you need to have a big enough use case to make it worth its while. And so there's a question here. So what are we building? So we're going to be building two things. One is a command line tool that goes ahead and makes a web request to get some data. And the other is an API, a web-based API that generates some JSON data that we're going to create. We're going to do all those things. And so the question here is, I wonder why AI and artificial intelligence and machine learning on Go is not as popular, assuming Google made TensorFlow for Golang too. Why any language catches for anything is always a mystery. I would say that the scientific community and the ones that were very much pushing AI and machine learning, what we would consider data scientists, tend to be a lot of actual scientists, and they come from quite a different background when it comes to coding. They tend to come from a statistics background, and then learn coding. And so they tend to learn those languages that they learn in university. And Go is not popular for those in those courses. They're learning other languages, usually like things like R or other, dynamically typed, easy to use languages. And then what happens is that this whole ecosystem builds behind them. So you could ask the same question, well, why isn't the C language popular in those languages? You can really make a lot of justification why it was this or why it was that. But the answer is there's lots of different reasons why that initial language catches. But once you have momentum, it's difficult for another language to really catch up. But I think what would help Go is all those very practical reasons. As these projects get bigger and more complicated, people are going to say, we just can't manage this project anymore. We need something that's a bit more manageable. So who knows? And while Go was created in Google, it's definitely not Google's language. Google doesn't push Go at all. It's not even used that much in Google either. It is used for a number of things, but Google's a massive company, and every language has to compete on its own terms. C is still way more popular of a language there, but it is catching on. It is catching on in time. But once again, once a project is created and already written in a language, switching to another language is not trivial and often not a good idea. All right, another question here. Does the compiled nature of Go hamper it somehow in the ML field. I don't know. That I couldn't tell you. I mean, notebooks are very popular, but I've seen notebook implementation because Go compiles very, very quickly. It doesn't really have any of the disadvantages of it being compiled. And so you'll see when we write the code today that it's not really that big a deal, running some scripted language versus running compiled language. And so the answer is, I'm not really familiar with the mathematical effects of that, but I know that Python is interpreted. Oh, familiar, yeah. Well, Python is a great language, and it is very good performance. For example, there are certain tasks, text processing tasks that Python does that can even beat compiled languages in. I think it's even beaten Go in some comparisons a few years ago. And being a compiled language doesn't mean it's not performant. The difference comes in subtleties like latency. Because Go is a compiled language that when you run it, it's already running. There's very little initial cold start time. And so I would never say a language is slow because it's compiled and interpreted or compiled. It very much comes down to a lot more subtle effects than that. So it's a difficult thing to argue in that way. All right, we are at 7:48. Hopefully everyone's back. So we are going to start creating some Go code. This is it. We're going to get hands-on right now. You're going to hear me typing on my laptop right now. So we're going to switch to a different screen. All right, here. So what are we going to do? So we're going to make a command line tool. It's the CACFAX command line tool. What we're going to do is grab some CatFacts from the web. It's super exciting, I know. We all love CatFacts. In this workshop, we're going to create a new Go project. We're going to compile a Go binary. We're going to create a function. We're going to create some variables, custom type, some structs, and I'll explain all of these as we go along. We're going to make a network request. We're going to decode some JSON and print out to the console. And this is going to include error handling as well. So yeah, we're going to cover a lot, but actually not in a lot of code. So one thing I wanted to say before we get going is if you are using VS Code, something you might want to make sure you're doing is that you do have the Go extension. This is it right here. You'll need this to make sure that the code looks nicely formatted. But if you don't and you can't get it installed, you actually don't need anything to write Go. Just a plain text editor is just fine. This just makes life a lot easier. The other thing you want to do is to install all the Go tools. Now, it should prompt you to do that, but if it hasn't, you can do from, where is it, Go, and where is it? It was the, I always do Control-Shift-P, I think. I forget what it's, the palette. Command-Shift-P or Control-Shift-P, and then you want to type Go tools. And you should come up with this install update tools. Pull that up and then just select them all here and install all of those if you haven't already. And these, once again, these are optional, but they add some really nice features, and I'll even touch on some of these features today. So if your system's working differently to my system, that might be why. I'm not going to do this because I don't want to download a bunch of stuff while I'm streaming. Awesome. So let's start in our terminal. Here it is. So please let me know if the font size is big enough and if it's clear. If there are any technical issues, please interrupt or write a message in the chat and we'll immediately address those. I'm in, where am I? I'm in my source code folder. So I'm in my users, my source, and this is my little project folder here. Now I'm going to make a new folder. And so you can create this anywhere. Hopefully your Go is working, by the way. I guess if you want to check if it's working, you can do go-version. And oh, I must have typed it wrong. Oh, what happened there? Oh, it's so big, it's hard to go back. Or is it? Oh, I don't need the dash. Oh dear. I don't write, it's not saying I type very often. There we go. So let's go clear, go version. There we go. So you should see something similar to that. I'm working on a Mac here, but it should work the same whether you're on any other system as well. So I'm going to make a folder. So on you know, Unix-based systems, it's going to be a make directory, and it's going to be cat. You can see I have my old version here as a reference, cat facts, and then hit enter. And then I'm going to, once you've created that, we want to go ahead and move into, so cd, change directory into cat facts. There we go. So create a folder. I recommend calling it cat facts because then you won't be confused. Hopefully you don't already have a project called cat facts. That has happened multiple times before, but you know, this will make it easier. And then, so inside of our cat facts project, as you can see right there. So now we're going to initialize our project. This is technically an optional step, but it will make your life easier if you do this step. So we're going to go mod. This stands for module, and init. And then we're going to call this, we're going to give it a project name, and we're going to call it cat facts. So go mod init. So we're using the Go runtime, the Go compiler, the module. This is essentially the dependency management tool, Go mod. We're init, we're initializing the project, and then we're going to give it a project name. And then, and hopefully it will just say, oh, it's creating that. And when we list in our project, we see we have a file called go.mod. That's it. So let's have a look. What's in? It's clear. Oh, I won't do that. I'll just cat. See it right there. Go.mod. There we go. So that way you can still see the old thing. So we need to create a folder. We need to go into that folder. We need to do go mod init cat facts, and then you should have this file in here. You can see it's a module, and it's essentially a module in Go. It's sort of like a project, and then it's called cat facts, and this is the minimum version of Go it's using. It's just letting you know certain features that it supports. Right. Hopefully that is where everyone's gotten to. So now we're going to switch back over to our editor. So from within VS Code, I can either go to File, Open Folder, or Open Folder from here, however you want to do it. And then we're going to go into our folder, wherever you put that. So here we go. I'm going to open up my cat facts folder. So go to your editor, go to Open Folder, navigate to where you created that folder, and then we're going to open. There we go. Straightforward. And then we can see that I have one file in here, and it's that go mod file. And we're not even going to touch this. This is going to be unnecessary here. All right. So hopefully everyone has everything all together. So the next steps. You might need to. It might ask you if you want to trust the file, the folders. Yes, you can absolutely trust them. You are the author, nothing not to trust. So yeah, if that message comes up, just say, yes, I trust. Yeah, easy to go. So now we're going to create a file. So I can right click, or I can hit the create file button. And this is just, and it doesn't really matter what this file is called. But once again, if you do it the same as me, it'll make your life a bit easier. We're going to call this cat. So really straightforward, .go. And that .go extension is very, very important. We must have that. Otherwise, it'll look really, really weird. So creating a file called catfacts.go. And instantly we have an error. I can't have already made a mistake. This seems outrageous, but what is it saying? All right, if we highlight, is it going to highlight it? Well, I know what the error is. There it is. And really, it's saying your code, this is not a valid Go code. Well, the reason is, to be valid Go code, it must have a package name. Where is it? So we're going to write package, and we're going to call it cat underscore. Ooh. Oh, no, we're not. I was like, that's not right. Main, because we're creating a binary. We're creating an executable now. So our package is main. Very straightforward. There we go. Package main. So apologies. All right. And then what we're going to write is then func. We're going to create a function. Remember, I talked about we need an entry point. So this is going to be our entry point into our code. And this is going to be main. So func means function. The name of the function is main. And then we're going to use parentheses here. This will be where we put our input arguments, but we don't have any. So it's just 2 parentheses like that. And then we're going to use a curly brace like this to open, and then another one to close it. So we have a curly brace at the end of line 3 and another one on line 5 with a nice little bit of space in the middle here. So this actually, I mean, really, actually this right here is valid Go code. And this is now an actual executable, but it doesn't do anything. It would literally just start, run nothing and terminate, which doesn't seem like very exciting. So let's do something. Let's print a hello world. So we're going to use a package from the standard library. Now your code might do this for you, but I'm going to do it by hand. I'm going to import that package. So import out here above my thing, and it's going to be a string. So I need double quotes, and I'm going to write FMT for formatter. I think it's format or formatter. I'm not sure. It's the FMT library. Now you can see once again, I've made a mistake. What is going on? What is my error? And down here, it's saying the FMT package is imported but not used. Now this is a feature of Go. I can't compile this code, and this is to stop clutter building up in your project. It's saying if you don't use it, you can't have it. Once again, this is about making maintainable projects for large code bases with large teams. So these sorts of things are actually a feature of the language. So let's use that package fmt dot. So this is the package name. I'm accessing the package name here. And then it has lots of things inside of it. You can see there's a whole lot of things in there. So what we're going to use is print and then ln for line. So print line. And then we're going to use our parentheses in here. And then I'm going to type hello world, and you can type whatever you want. Oh, hello. And then we want to close that string, close our parentheses. That's it. There is no semicolon at the end. It is actually part of the language. This is valid Go code, but they're optional and usually removed by different tools. I think if I save now, it actually get removed. Save, yeah, it gets removed for me. Now, the other thing that the editor will do is also automatically import packages for you. So if I cut this here, you can see, oh, it says you haven't imported this. Do you want to fix it? But if I save, you can see it automatically adds it for me. So that makes your life a little bit easier. But I did it manually first to show you that it's part of the process. You need to be aware of it. You can't necessarily always rely on your tools because sometimes they mess up. So that's it. We have it. We have our binary. We have our executable package main. We have an import format for FMT package. We have our entry point, the main function. And then I'm calling a function inside of the FMT package called print line, which will essentially print my inputs with a new line at the end. That's all it means. There's also just print, and then I could do a new line myself. Where is it? I've got to use that weird key combo. Oh no, that's it. No. There it goes. So these are, that would be equivalent. So print line and this are the same thing. They're equivalent, but we'll use the built-in tool for that. So save. Now my other editor that I normally use always saves for me, so I'm always forgetting to save. So you'll probably see me do that another time. But now we're going to build this. We're going to build it. So let's pay attention to what we have. We have a Go mod file, we have a catfax file, and nothing else. So let's go ahead back to our terminal. And list it out. I'm going to clear the screen and I'm going to say go build. And then I'm going to hit enter. And then you can see that I now have something else in my folder. If I list here, I have a catfacts file with no extension on it. This is my binary. It's been compiled. Now, if you're on Windows, that will say catfacts.exe, but it's essentially equivalent. And to run this on my system, I need to point just to the current directory and then the binary name, and then hit enter, and it'll say, hello world. So hopefully you've all gotten to that point. You have created a catfacts.go file with a main package, a main function, and you've printed something out. This is very, very helpful for debugging your code later to know how to print things. And then in our terminal, we just type go build, and then we run the binary. That's it. We've built our first Go code. All done. You're all professionals at this point now. So hopefully no one has any issues, but and so what we'll do is we're going to move on to the next step. We're actually going to build our app. So what we're going to do is use this service. I think I have the window open here. So here we go. So this is our website we're going to use, catfact.ninja/fact. This puts out some JSON code. Let's do the raw. So here's the raw JSON you can see here, and every time I refresh, I get a slightly different fact and also how long that string is. Very, very nice website there. You couldn't be more perfect. So let's start building this out. What do we need to do? Well, the first thing we're going to do is go and get that. So so hopefully you guys can see this. Right here. All right, there you go. There's the address. So you'll need that address, in just a moment. So we're going to use the HTTP package. So HTTP dot, and we're going to get this. We're going to make a get request. So get. All right, and then we do the open parentheses, and then I'm going to get my URL here. Oops, that easy. And it's a string, so I need the double quotes from the front and back. I can remove that now. And the problem it's saying now is I don't have that package installed, so easy peasy, I can just do it over here. So there we go, save that code, and it's just being silly. Right, so there we go, but this does return something. So if I hover over the get command here, if I save, what is the problem here? Oh, I know what the problem is. That's not the name of the package. It's net/HTTP. Trying to write these piecemeal is difficult. Right, so here we go. Oops, a daisy. Right, there we go. So it's net/HTTP. Oh, someone said to me as well, thanks very much, Peter. And here we go. If we hover over this, we now have our code. And you can see here, it takes a URL as a string as the input. And here is our return. We get a response, which is a pointer to an HTTP response, and an error. All right. So let's go ahead and create some variables now. So we're going to create our first variables. We're going to do RSP for response and ERR for error. Every error in Go is always called ERR. It's industry standard, apparently. I think it's fine, right? But I've got an error. I mean, once again, I didn't do anything and I've already made a mistake. So if I hover over this, it says ERR declared but not used. So much like a package I've tried to import but not used, the compiler is going to say, no, you can't do that. So that's all right. So let's use them. We're going to have to use them, otherwise you can't compile our code. So we'll do a new line, and we're going to say if ERR is an exclamation point equals, so not equals, to nil. This is Go's equivalent of null. Nil is their equivalent to null. So If the error is not nil, that means there is an error. It's sort of like a double negative in a way. So if we have an error, run this code. Okay, so what code are we going to run? We're just going to print the error out. So we're going to use the format package again, and we're going to do our print line. And we're going to say there's an error. Make it nice and clear. And I'm going to pass error as the second argument here. So right, that error message has gone away. So format, print line, our error message, and then error there. Then the next one is response. But what I'm going to do right now is use an underscore here to say I don't need this variable. So if this ever comes up, you can use an underscore to say I don't need the variable. So I'm going to go ahead and run this code. But what I'm going to do first is change this URL to show you that the error is working. So we have to test our code. So I've got to test my error handling as well. So you don't need to do this. I'm just going to show you. So I'm going to say clear, just to clear the screen to make it easy to read. You don't need to do this step. And I'm going to say go build. And then I'm going to use this to run another command if that one succeeds, and that's going to be my cat fax. So this is just a one-liner to clear the screen, build the code, then run the code. Run that. Oh, and it didn't work. All right, so let's do go build. That's fine, and then I'm going to do cat fax. And that didn't work, right? Let's go look at my code. What did I do wrong? I did something wrong. It didn't work as expected. So it's saying that this is valid. Maybe if I made it even less valid, let's do X like this. All right, save that. Maybe there is an x.ninja website out there. Here we go. So apparently x.ninja exists. So my bad. So here we go. We've got error, and here's the error message get, and the URL. It's no such host. So it doesn't exist. That's what we expected to happen. So you don't need to do this part. I'm just showing you that's how the error handling works. So we're back to normal again. All right. So we've checked our error, and this is the thing of Go. We always handle our errors right away. Now, if there is an error, what I'm going to do is return. This is to say, I just want to end execution of this program. I'm returning from this function. So that's totally fine. So if we get an error, print a message and stop execution. That's what we're doing right there, return. All right, so now we're going to go back to our response. And what we're going to do is we're going to do a little bit of debugging, see what we get in our response. So we're going to use our format print line, and we're going to put the response in there. And then we're going to build and run that. Oh. I didn't save. See, I always forget to save. So get your response, put it into the print line, and then we're going to build and run. Right. Wow, that's a real screen of text. But you can see there's something in there, but it's really hard to tell what's going on here. Well, we know 200 is an okay message because we just know that. It's like a map. All right. Well, let's make this a little bit easier to read. So what we're going to do, and the reason I bring this up is that this is a common debugging trick that I want you all to know. So this is something to take note of. We're going to use the printf command. This is essentially a templating language built into a print statement. And we're going to say response, and we're going to use the % symbol, the pound or hashtag symbol, depending on where you're from. And then we're going to use V for variable. All right. So I'm going to save this. So this is really important. This part right here will help you get a bit more detail about what you want to know about. So let's go back to our terminal. Did I save? Save. Yes. Run our clear build thing. And now we can see we get a bit more data. So we have our message. So we can see this is an HTTP response, which we knew we were going to have. This and means it's a pointer, which that thing did say it was going to be. The status here is 200 okay. Status co is 200. So this makes a bit more sense. This is a bit more, we can see what's going on, but we don't need all of this, of course. We want our cat facts. All right, so how do we dig out the cat facts from this? Well, the cat facts are in the body of the response. So if we add .body and save that, let's see what we get next. All right, we get something, but it isn't really very useful, is it? All right. And the reason is that this, the actual body is hidden inside of an interface we need to read the binary, the bytes out of. So let's do that. So there's at least, there's not really tenants very much. We can see there's a stream client here. That sounds sort of makes sense. All right, so let's read that out. So we can see the body here. It implements, it's an IO reader. Okay. So we have a tool that will allow us to work with this type of interface. So we're going to import another package. We're going to do IO, because it's an IO reader, read, oops, a daisy, read all. And then save that, should import my package. And oh, I get an error. I can't put it in there because it has an error response. So let's go down here. So we have our body error, ERR, save, all right. And we're going to check to see if the error is not equal to nil. And then we're just going to copy this one. And here, and then we're going to update our message. And this is going to be error get. This is going to be error read. And then down here, we'll throw body in here. So what we've done is we've taken our response body. We've thrown it into the read all function. And we then are getting an error and the body out, checking to see if there's an error or not. So copy and paste the code above, and then just we're going to dump this out. So let's save that. Clear, build, and run. Oh, and there we go. We've got ourselves a collection here, a slice of bytes. So it's not very helpful. I can't do anything with bytes, but in Go, lots of things are bytes, and they're actually easy to turn into other things. So a string in Go is bytes. So all I have to say is I'd rather see this as a string. So yes, we have a strict type system, but I can convert variables to other types and just reassign them to something else. So I'm going to do that. I'm going to say I want a string. And I do that by just wrapping it in parentheses and typing string correctly. Here we go. Save that. So now we've got the same code as before. And we've just added string and parentheses around the body. And we're going to print that out. I'm going to run that. So clear, build, run. And there we go. Here is our JSON data. It's actually there for us to use. So that's fantastic. Now, what we're going to do is we need to decode that value. So Go has a JSON. Fantastic. I didn't read the caption. that is a great cat fact. This is the fun part about using this one as a tutorial. All right, so we need to now decode our JSON data. But first, I want to define the type for it to be decoded into. Go is a strictly typed language. I can't just have random data, so I need to define that. So we're going to define our own custom type. So above here, it can be anywhere in the file, but I'm just doing above function. I'm going to do a new type. So it's a type. Cool. And this is going to be a cat fact. Easy enough. And this is going to be a struct. So what a struct is a collection of other types of values. So it's just a collection of other types of values, but specified. So I'm going to say fact, and this is going to be a string, and then length. I'm going to type that correctly. And this is going to be an int or an integer, a number, essentially. So here we go. So that's our custom. So we've created our first custom type. It's all done. Fantastic. So that was needed for this next step. So what we're going to do is have a fact here. We're going to say we want a variable, and it's going to be a fact, and it's going to be a cat fact. So here we've defined a new variable. And now I'm going to pass this into, well, we know what to do. Let's go ahead. And we're running a little low on time. So now we're going to decode this. So I'm going to use the JSON package. And I'm going to use Unmarshall. And there's a few different functions. They all do something different. Unmarshall is what we want to do when we want the data itself. We're going to give it body. And we're going, because this is the data we want to unmarshal. And then we're going to pass in fact. But we have to pass it in as a pointer. So the way we do that is we use the and. So this means that it can make changes to the variables that we pass in, and we see those changes. Otherwise, we can't see those changes. And then I'm going to throw fact down here. So we did a number of steps there. We created a new custom type, cat fact, which is struct, has two properties on it, fact, which is a string, length, which is an int. And these are making sure that these match the values that come out. So fact right there and length right there, they need to match. Otherwise, we need to do some extra steps. And then I'm declaring an instance of that variable or value of that type. Sorry, so I've got a cat fact value now. And then I'm using JSON unmarshal, giving it the body, passing the fact, and that's going to take all the JSON and put it into there. So let's save that and see what we get. All right, and there we go. We have a cat fact with the fact right there and the length. So we now have those values, but I want this to look a little bit nicer. I don't want to print out this debug code. So the final step is we are just going to print out the actual fact. So we're going to say fact dot fact, and there it is. And we're going to change this to a line. So print line fact dot fact. It's a bit of a stutter there, but let's go back, clear build, and there it is. I can now run my cat fact multiple times and get a different fact every time. Fantastic. Now we need to do a little bit of cleanup. There's one step we need to do. You don't need to do it, but I want you to be aware of it. And that is that when we make a request, we're holding on to a connection to that website. So we need to have something that lets go of that connection. And the way we do that is we use the defer function. So this will run the code when this function returns, and we're going to call body, response dot body close. This is optional because we're not really, once it exits, it also lets go, but this is very important for when you write your real code that is long lasting. So there you go. That's the final step. So we're all done. And I can see we're almost at the end of time. I don't know what we want to do as the next step. Sasha, what should we do with our last 10 minutes?
Well, you know, we're not Cinderella, and our carriage won't turn in a pumpkin. So let's go for it, definitely.
All right, well, I apologize to all the people that had a real strict amount of time. You've done the first exercise. That's a real good introduction. But now we're going to move on to the next one. And so this next one, oh, today's it. Now I want this. Right, our next thing is the pet name web service. So let me pull up my notes for this. And so what we're going to do is we're going to make, just like the cat facts was a web service that generated JSON, we see that right here. This is a web service that generates JSON content to return to us. We're going to create the same thing. We're going to create a web server that returns some JSON code. And we're probably going to just do the first, we'll break it up into different parts so people can drop off at decent times. And one thing we're going to use is we're going to use a library that's a pet name generator. So this is the library here by this awesome developer, and I'll show you how to get that in there. And I'll actually share this link here into the chat so you can grab that, because you'll need that in a little bit. So in the chat is that URL. So just hold on to that for now. And then we are going to go and create a new project. So let's get our terminal. So let's jump out of catfax. So we'll go up a directory. And we're going to make a new folder. And this one is going to be called, what did I say it was going to be called? Pet names. So pet underscore names, plural. We're going to move into that folder just like we did before. And we're going to initialize it by doing go mod init, and we're going to call it pet names. Go mod init pet names. So that's it. It's the exact same thing as we did before. So we're going to create the pet names folder, move into that folder, say go mod init pet names, and there we go. And so now in our IDE, we're going to open that. So go open folder, and then open your pet names. Oh, why can't I see it? Oh, it's because it's ordered by. And then we have an empty folder. So that's the initial part. So while you're doing that, so what we're going to learn in here is we're going to learn about using local packages, the modular design part, a little bit like classes, a little bit like namespaces from other languages. We're going to use a third-party package, which is the URL I gave to you. We're going to write some tests. We're going to write some system tests. We're going to create a web server, and we're going to encode a structure to JSON. And the reason I did all these things is this is what we do a lot in our most Go code is encoding and decoding. And it'd be nice to work with databases too, but we don't have that opportunity here. So the next thing we're going to do is create a main.go file. So I'm going to create a new file, main.go. It doesn't really matter what this is called. And then we're also going to create a folder called server. So new folder, server. And in this folder, we're going to create a file called server. So we have main.go. We have a folder called server and a file called server. All right, it's pretty straightforward so far. So the first thing we're going to do is go into our server.go file. And this is going to be our local package. So we're going to call it package server. So it's our server package. And as weird as this theme, this is what we do all the time, just very obvious names. And then what we're going to do is just create a function here, but this time it's called server. Oh yes, someone reminded me that I said that you only needed 113 as a minimum, but I used something from a later version. Thanks for reminding me. I'll fix that. Right, so here's our server function. It doesn't take any arguments. And here. Now, instead of printing, we're going to use a slightly different package this time. We're going to use the log package. So instead of just printing raw strings, we're going to say log.println. And here we're going to say starting server. This is really, really useful. It sounds weird, but that way you know the code is running. Sometimes you doubt yourself. It's all right. That's all we need to write in this one right now. So we have our package server. We have our import for the log and our function server. I know this seems really, really simple, but what we're going to do is now use this package from our main. And that's the key thing here. And that's why we did it this way around. So hopefully you've got that code. essentially just print something out saying it's starting. Oh, panic line, print line. Here we go. That's better. Print line. Oh my gosh, panic line is definitely not what we wanted. So now hopefully you've got that. We're going to go over to main. So the package here is always going to be main. And we need an entry point. So func main. That's our entry point with the curly braces. And now we're going to import our package. It's a local package, so we can just use, when we import it, we always do it from the root of our module. So we need the module name. So we're going to say import, and the name of our module is, hopefully if you followed me, pet names, pet underscore names. And then we use a slash, like a folder structure. So we're doing pet names slash, and then our package, if we go back here, we called it server. That's the package name. So in main, we just say server. Right. So that's going to import our package. So I can now use server here. So I go server, and you can see here it's already sort of suggesting things for me. Dot, so accessing things within that package name, server, and run it. Save. So that's it. So what we've done was we've imported the package and we're running something from within that package. So now we can go to our terminal. We can just say clear. Once again, this is just optional to make it easier for the thing. We're going to say go build. And I want it to run pet underscore name. It hasn't been created yet, but hopefully it does. There we go. So as you can see here, we got a timestamp. So this really helps with debugging. So that's a nice feature there. And starting server, and then it execute. There we go. So that's the first thing we've learned. We've imported our package. All right, so what is next? So we're going to do everything now inside of server. I don't think we'll do anything else in main. And that's generally how you want to do things. You don't want to do anything in main. You want to do everything in these packages. So we're going to create a handler. And this is going to handle incoming requests. We're going to do a real simple one first, just for the homepage. So we're going to say func. And it's going to be a little bit complicated, but then it'll be really copy and paste after you've done the very, very first one. So we're going to call this home for homepage. And then we're going to use W as our name of our parameter. So this is going to take input arguments, which we haven't really talked about, but this is you just copy exactly what I have and you'll be good. So W, and then we're going to say HTTP, and we're going to get the response writer. So that hopefully then should import the package for you, the net HTTP. If it doesn't, you need to import this. That's one. Then we use a comma, and then we need another argument. So this one is going to be REQ for request. And this is a pointer, so we need a star here. And we need HTTP again. And this one is just request. There we go. And this then doesn't return anything. And that's sort of the template right there. So it's important that you get this bit exactly right. I'll throw this code into the chat to make it a little bit easier as well, because that's a bit much to type. And if someone's system's not working quite right, I would hate for you to get stuck on that. Apart from that, this is going to be really, really easy. And then we're going to use the format package again. And this time we're going to use it to write out to another writer. So we're going to use the F function, F print. And this takes the W as the input. And then we're just going to say, welcome. If I save that, it should import everything. Oh, what was my error? Oh, it's unused. That's fine. Right. Right. So the question that came in is why are we using a pointer for requests, but not for the response writer, for request, but not response writer. So this is how they are going to be passing down a lot of data, awful lot of data that comes in through here. So this is one way to save on memory overhead. Now, whether you should or shouldn't do that should be based on performance analysis, but often it comes down to having efficient code. So they've made a choice to say, this is what we need to prevent us from copying all the data within there. But there's no real reason apart from based on analysis and design work and benchmarking. But it's not a particular, usually it's going to come down to efficiency a lot of the time. Right, so next step, and I'm really oversimplifying there, so I apologize, but yes, that's essentially it. So we're going to leave our log statement in there. And now we're going to write http.handle_func right there. And we want to do it for the root of the site / and we're going to say home. Now, if you made a mistake here, this is where you'll get an error. So let me remove the start here, and you can see I got an error because this is expecting an exact type of input, an HTTP pattern. It's got to be this exact format. See, handler that takes this and takes this. So that's why you'll know if you've got it wrong. So yeah, if you're seeing a red squiggly there, you've got this part wrong. So that's awesome. So we've set up a handler. So now we just need to go ahead and listen for incoming requests. So we're going to say, we're going to use the HTTP listen and serve right here, listen and serve. And we're going to do it on port 8080. I hope I don't have anything running. I think I do have Docker running. Let's stop. I just realized that. There we go. I didn't want that to be an issue. All right. If you have something running on 8080, just put it on a different port. It doesn't matter. I'm just putting it on 8080 here. And then we just say nil, because we don't need to pass anything for this second part, because we're setting them up here essentially. Now this will work, but this is not the best, because if there's an error, you're not going to see it. So we want to capture the error that's returned from this. And once again, we're just going to say, if error not equal to nil, then we're going to log print line, and we're going to say error, and then we're going to pass in, and then we're going to say at the listen and serve, and then we're going to pass our error here. Right, this is everything. So what have we done? We've created a handler down here called home. It has to follow this exact format because it's got to be compatible with this handle func. In it, we're using the fprint command to write something into this incoming response writer. You see, it's a very specific interface that has some different things we can write. This is the one we're specifically using right here, this write. We're then passing in a string that will be written to our W value that comes in. Up in our server, we're then binding that handler to the root of the folder. And then we're starting our web server on port 8080, and then listening for any error. So I'm going to save that, come over to here, do my go build, and then run the pet names. And it says server starting. Well, huge success. Now you'll see it hasn't returned yet. That means it's still running, it's blocking. And actually this web server is multi-threaded. So it can actually use all the CPU cores without you doing anything. So right now you're already running some multi-threaded code. So let's go into wonderful Firefox over here, and we'll switch this over from the catfax, because I've already zoomed in, to localhost 8080. And you can, oh, it's not zoomed in. Where's my plus button? There it is. Oh, there it goes. Zoom it in. There you go. We've got my welcome. I'm just zooming in so everyone can see it. So there it is. So that's it. That's our homepage done. That's, you build a web server, guys. Fully functioning web server, production grade. It's good to go. Probably a few little tweaks, but it's not really far from the truth, to be honest. Right. So now we actually need to build our pet names handler. So let's grab and copy this line. Well, let's just copy the whole thing. And we're going to rename this to pet names. All right. And then here, we want to do two variables. We're going to do words for the number of words we want in the pet names. This is going to be 2. And then we're going to do separator. And this is going to be a string. And this is going to be just a dash. And then we need to get our package. So let's go do that. So what we're going to do is go over to the terminal and we need to pull in our package. So I need to kill my web server. To do that, we're going to do Control C to terminate the running web server. There we go. It's done. And now I need to pull in that dependency. So I'm going to go get it. Literally, I'm going to go get. And then I need to type in this string here. So you can see github.com/ oh, it's missing the end part. Oh, that's right. My code is being switched. I'm just going to, there we go. And this needs to be Golang pet name. There we go. It's sort of wrapped over. I hope that, but go get github.com/Dustin Kirkland, Golang pet name. If there's any errors, we'll soon see. So let's try and run this. And there we go. It has added it. It says right in what version it's added. Essentially, this is the Git signature. And if we go over here into our Go mod, we can see that it's added that as a dependency right here. And it's also saying it's not being used, but that's okay. We haven't used it yet. So let's go ahead and use it. So let's repeat that one more time. So go get, and then go get this long string. Hopefully you can copy and paste it. And then it should, if everything's successful, it'll just say it added it. And then you should see in your Go mod that this require has been added. So this is the dependency management right here. So right now we've learned how to use external open source code. Oh, if I did that, oh, that's a lot easier. So my formatting on my notes was all weird for some reason. All right, so now we go back to our pet names. So we want to use that. And unfortunately, it's done a bit weird. Yeah, so someone was saying, are Go mod and Go sum similar to compose.json and compose.json lock? Yeah, absolutely same. And also for Node, you know, it's like npm, similar concept. They learned from all those package managers. Package manager came quite late in the Go life cycle because they really wanted to get it right. All right, so we're going to use that one. So it's called the pet names. Oh no, what is that package called? So can I? I think it's just pet name, isn't it? Pet name. Yes, generate. There we go. So you can see here, it adds it a bit weird. Normally, the package name matches the last folder of the URL. It just doesn't in this case. So they've added that name to help you out with that. And we want pet name dot generate. Easy peasy. And then the next thing we're going to do, is pass in words and separator. Awesome. That's going to generate our pet name. So let's then copy our line from above here in home and just paste it in here to print that out. Save. Right. It's not being used. No worries. So then we've got our pet names function. Let's add it to our web server. So let's copy and paste this line. And we're going to do, this one is going to be called, what did I call it? Names. And we're going to copy this function here and call it names. And that should now work. So let's save that. Go in here, do clear, build, and run it. It's running. So let's go over to our browser and do h/names. And there we go. We have got our pet names. That is awesome. So the last thing, and this lesson goes on, but the last thing I'm going to do, we're not going to quite get to the, oh, hold on one second. All right, so here we go. We're going to grab some variables for these here. We're going to grab them from the request. So req URL query, because it's the query part of the URL, get, and we're going to get words. And you can see the words here returns just a string. So we can just, right here. Now, here's a key part. I don't want to have this part here. This little colon equals means that I want to initialize a variable, essentially. I want to define one. But when I just want to assign something, then I'm just doing equals right here. And I'm getting an error. Oh, yes, because and my error is, oops, daisy, it went too far. That's right. So the reason this is not working is that words is a number. And what was returned from here is actually a string, and I can't change that. So let's first do words string. And what we'll do is we need to then convert this to a number. So we can use the string str convert package, and we're going to do a to I, ASCII to integer. And then we'll do, I guess we can just pass this right in here. Let's simplify things. Yes. And then we'll grab words int, oops, words int, and then error. All right. So have I got this wrong again? Oh, I haven't saved it. There we go. So if my error is equal to nil, then I know this worked. So then I can just use words equals words int. So here we go. So what I've done here is I've grabbed the words from a query, the number of words that is, and converted it to an integer, but that could go wrong, right? So I'm just going to say if there was no error, great, then convert that and use that here. So I'm doing sort of the shortcut version here right now, which is why it's a bit rushed. So apologies for the long running. So now if we go and compile our code, so I'm going to Control-C to kill it, build and run, excellent. Go to the browser. So this should work as normal. But if I add a query, and it's kind of hard to see, unfortunately, on this screen, because I can't zoom this bit, but if I go question mark words equals 5, for example, then I get 1, 2, 3, 4, 5. There you go. So we'll call that a day there, because I know I've really taken up a lot of you guys' time over that. You know, so we didn't get into testing, unfortunately, but what you've got there is a full web server that can take query requests, print things out, and it's fully loaded there. So apologies for the long overrun. That'll take us for that workshop. Hopefully everyone had got that. And yeah, I guess you're free to ask any questions and I can answer them and we can get to anything. Oh, yeah, you guys are welcome. Yeah, feel free to ask any questions. I'm here for you. Hopefully you found that straightforward and we're able to code something up.
Thank you, Sam. I think that you promised to share the link to your book at the end of the workshop.
I did.
You did?
Oh, okay. I do not have that link handy, so let me pull it up. All right. They actually are having me do a second edition right now. So that is what I'm working on in my free time. So here's a link to the publisher's website. But it's also available on Amazon as well. But that's the book. Yeah, hopefully, yeah, it's really great. I love the book. I'm really proud of it. We worked really hard. I did all the introduction chapters. So the first 5 or 6 chapters, the introduction and the first few chapters are all me, and then it goes into the other guys with different specialities. So I go into the type system and how it all fits together in a lot of great detail and really cover all the different edges. So hopefully you guys will enjoy that. And then, yeah, in about a year, there'll be a second edition. so no need to wait. So there's a question here. What stuff should we learn next in Go? Maybe if you want to apply as backend dev. So I would definitely say start looking at connecting with databases. Really, really important aspect of working with Go. What else would you've really got a lot right there. So you've got the command line tools, you've got web servers. Testing, we didn't get into testing very much today. Obviously you want to be able to do that. What year is the book published? Oh, that's a good question. It was 2019, so 3 years ago. The only thing that book doesn't really cover, I think modules came out in that time, but we went over it today, so you're already familiar with that. And then generics, which is literally released a couple months ago, so it doesn't cover generics. But those are but it has all of the foundational stuff is all exactly the same and still very relevant. So what about a second event with more interesting Go projects? Yeah, of course, if the wagon thinks I did a good job, I'd be happy to come back and help you guys. Got thumbs up there. We can do a two, because I have all the content right here. What did we miss out on? Yeah, testing. I didn't get into automated testing. There's also web server testing. We didn't do JSON encoding. And I also want to do some concurrency. I didn't fit it in today because I didn't think we'd have time, but you know, it would be great to do some concurrency work with you guys as well. Yeah.
Definitely. We already have 2 people in the chat asking for that, so we should. Three people.
So awesome. Yeah, yeah.
All right. A lot of people asking.
Well, thanks for everyone for being so patient. Sorry I overran. This is the first time I've done this one, and an hour and a half went a lot quicker than I expected. I thought, oh, I was honestly expecting at the end to have a good 20 minutes to chat and hang out. I thought, well, 20 minutes is fine. That's good.
All right, yeah, then let's let you go enjoy your evening and take a rest after almost 2 hours of the nonstop workshop. Yeah, thank you so much, Sam, and thank you so much for the whole abbeal team for making this happen, for arranging, organizing, and delivering this workshop. Looking forward to having more cool Golang workshop with you, Sam and abbeal. Have a great evening for those based in Japan and in Asia, and have a great afternoon. Maybe those of us joining from Europe. I think someone also joined from Colombia, probably like early in the morning. Yeah, thank you so much, everyone, for attending Level workshops, and thank you so much to abbeal and Sam. Thank you.
Thanks, guys. Have a great evening.
Bye.
Have a great rest of the day.
Thank you.